So welcome everyone. This webinar will go on for about close to 45 minutes. After that, we would be opening the session for Q&A. You can post your questions in the chat and we would be taking them up at the end of the session, at the end of 45 minutes. So here we go. So the agenda for today's webinar is I would be taking you through the introduction of what is DS Lab and a brief overview about it. Then what are the features available in DS Lab and the advantages of DS Lab. Then I would be taking you through a demo of a sample use case in a notebook that we created in DS Lab. And this notebook would actually help us understand all the different features of DS Lab. And then at the end, we would just be looking at the very high level roadmap of DS Lab, the features that we intend to achieve or release in the upcoming months. So what is DS Lab? I know this name sounds pretty interesting and it might spark a question in the minds of the audience. So DS Lab is actually a comprehensive ecosystem that provides data scientists with a platform for quick experimentation and immediate productionization of models developed from such DS experiments. It also provides collaboration between data scientists where they can jointly conduct experiments, share notebooks, models, and other artifacts with the team. So many people who work as data science professionals in the IT industry, I'm sure you would have come across a Jupyter notebook or Google Collaboratory or the notebook feature available in Kaggle. So this is one of the standout features that we are providing from DS Lab. So we also have a notebook that we provide from DS Lab, and it has all the features that you make use of in a Jupyter notebook in Jupyter Lab, or a Google Collaboratory notebook in Google Colab, or the notebook from Kaggle. But the beautiful thing about the notebook and the other features in DS Lab is that it allows you to create your experimentation in the DS Lab environment. And then once you are done with the experimentation and you are satisfied with the result, then it gives you an opportunity to productionize your model immediately. So this is something that usually data scientists they struggle with, because I, being a data scientist, I realize and I know this dilemma. Once we create a model, then productionizing it becomes a challenge, and it is a huge task in itself. I might want to go to Azure or AWS or Google Cloud Platform. So that involves a separate process or a mini project in itself. How do I productionize my model? But in DS Lab, we are providing a complete ecosystem. So you not only get the opportunity to create a notebook, do your experimentation, create your models, but at the click of a button, you can also productionize your models to production, to our data pipeline. So how did we come up with this idea of DS Lab? So I just briefly mentioned to you that the dilemma that data scientists usually face is when they come up with a model and then they wait for someone else to productionize that model. Now, this is something that takes a lot of time and it takes a lot of skill, especially people should be knowledgeable in cloud technologies, how to work with AWS, how to work with Azure, how to work with GCP, and how to set up your cloud platform over there. And that is a very big process in itself. So how do you actually take the models and productionize them, and where do you do them? So we have tried to cut out on this complexity, and we provide data scientists the ability to just use a click of a button and you can productionize your model to our production data pipeline. So as you can see, this is the schema or the diagram of our data platform. And we have the data ingestion component, which is the data center, which has two components, data services and data sandbox. Using data services, I can ingest data from any database. It could be Cassandra, it could be Hive, it could be MS SQL, MySQL, MongoDB collection, you name it, or PostgreSQL, you name it, and we have a connector for that. And using that connector, we can connect to the database. We can get a snapshot of the database and create a data set. That data set can be consumed inside DS Lab. So we can consume that data set in DS Lab. At a click of a button, I can create a data frame. So I need not bother that I am getting my data from an SQL DB or from a MongoDB. So what is the syntax that I need to write in order to read that data into a data frame? We already hide that complexity in the backend, and at the click of a button, we provide you with a feature that you can immediately consume that data into a data frame. So that is also a feature that is very helpful, and I'll just show you how we do that with a simple example of reading a CSV file. So data sandbox is another component of data center wherein we can upload CSV files or Excel files or text files, and those files can again be consumed in our inside our DS Lab, and we can read those files into a data frame, and then we can start our experimentation inside the DS notebook. So once we are done, say for example, for working on a supervised learning use case, then we usually come up with a model. The data scientists would agree to this. And once we have a model, how do we productionize it? So we have two options here actually. So one option is we can publish that model to pipeline, which is our production pipeline. And once it is published to pipeline, there is already a component in pipeline, which is known as the DS Lab model runner. And that component will actually run the model which we have published in pipeline, and it can be used with in conjunction with other components of pipeline that could be related to data ingestion, or those could be related to writing data to the database like MongoDB or MS SQL or any other RDBMS. Then we also have the option of publishing this model to another service known as model as an API. Now, once we publish this model to this service called model as an API, this model can now be consumed in downstream services. So this is also a very powerful feature that we have released. And I'll be showing you a small demo of a very basic mobile application. Now, this mobile application gives you a screen and allows you to enter certain data in the screen. And at the backend, I'm using my model that I create from the DS Lab notebook, and that model is being used as an API. So that model is being used as an API to serve predictions on my mobile application based upon the data that I enter in that mobile application. So this is also an extremely powerful feature that you can make use of, and you can consume this API in any of the processes that you have associated with your platform. What are the features in DS Lab? So as I had mentioned a little while ago, DS Lab gives us a very comprehensive ecosystem wherein it allows data scientists to not only do their experimentation in the DS Lab notebook, but it also allows us to productionize the models that we create out of those notebooks. Then what are the frameworks that we support? So usually we have come up with a project like setup. Now, when I say project, what do I mean by a project? So a project is nothing but an entity, which is a collection of several elements. You could imagine a project to be a collection of notebooks and data sets and models and probably scripts. So this project is nothing but a data science project, and it would be making use of ingestion components like data sets from where I need to read my data. Then it would also include notebooks where I actually do my experimentation using those data sets. And then in my notebook, I might create several artifacts. I might create several CSV files. I might create several plots. So these are also part of my same project that I create for my DS experimentation. And then also we have the option of saving the models, and the models are also part of a project. So we provide a whole umbrella inside DS Lab called a project. And within this project, you have several elements that you can make use of vis-a-vis a data set element, a notebook element, a model element, and also an element of utility scripts using which we can upload Python scripts that can be used in our DS Lab notebook. So the frameworks that we currently support are TensorFlow and PyTorch, and you can write any code related to TensorFlow. It could be machine learning algorithms, supervised, unsupervised, or you might want to run deep learning algorithms, neural networks, computer vision, natural language processing, you name it, you can run it on DS Lab. We also have provided PyTorch frameworks, and if you are working on any PyTorch module, you can run using the PyTorch framework as well. We also provide the ability to configure memory and CPU and GPU as well. Now, GPU facility would be enabled in the coming weeks. Right now, we only have the ability to configure memory and CPU usage for your notebook. We also provide users with the ability to enter libraries or external packages that they want to run along with the experimentation that they want to do. For example, I might be working on a use case where I have to read data directly from AWS or an Azure blob. So I might need external libraries like Boto3 or Azure Storage Blob. So those libraries I can mention in inside the project uh, screen. I'll show you that. So those external libraries you can add, and anytime you can import them into your notebook once you have added them in the external libraries field. They'll get installed in the backend, and you can import in your notebook, and you can use those external libraries or those external packages. The ability to provide access to granular data sets. So as I told you, we have connectors to n number of databases, and you can ingest data from those databases. You can get a snapshot of those uh, databases into a form of a data set based upon the condition of the filters that you have. And in fact, we also provide the user to specify the filters. For example, you're reading data from an SQL database. So you will say select star from your database where something is equal to something and something else is equal to something else. So you are providing a where condition, a where clause, where you provide information or filter based upon which you get the values out of the database. So we take that snapshot and we also provide the user these filter options in the Node DS Lab notebook itself, wherein you just need to mention the column name and the data set will get converted into a data frame, and you just need to run the cell at the click of a button. So you can see we hide away so much of complexity, and we provide user with a very seamless interface, a very simple interface. The only thing that he needs to know is where do I read my data from, and that's it. He can specify it, and he can just run the cell. The code gets pre-populated, and the data gets converted into a data frame. He can start his experimentation without the hassle of trying to understand what database is this, what is the syntax of trying to read data from this kind of a database. And there could be so many iterations if there is a mistake that happens. So we do away with all that complexity, and we give a very seamless interface for that. I'll show you how to do that with a very simple example of a CSV file that we read. So we also have the ability to share the notebooks, models, artifacts across the projects. The project is the larger umbrella under which we have different elements which I talked about, namely notebook data sets, models, and they can be an artifacts as well. They can be shared across different project team members. Now, this feature is currently not enabled, but in the coming weeks, it is going to be enabled and it will be ready to use. So we also have the ability to collaborate as we know that we can take in data from so many different databases. So this DS Lab can interact with a whole set of RDBMS databases and different sources of data from where we can read data and start our experimentation. We can connect to any database with the database connectors, and we can also import data from our data sandbox. So data sandbox is nothing but it is a centralized network storage location wherein we upload all our CSV files. Mostly data scientists, they might work with CSV and Excel files, and you can store them, you can upload them in data sandbox. It is a centralized network storage location. And once you have stored them there, you can access them in the DS Lab notebook. So we have comprehensive features for creating, uploading, and downloading of notebooks. I'll show you that you can download your notebooks in the form of an IPYNB Python notebook format, or in the form of a script, or also in the form of an HTML. So we can save models. As I mentioned, if you're working with a supervised learning use case, you can save models, you can load models, you can do prediction from models, and all of these things you can just do from the click of a button. You need not write code for that. So that also it does away with the complexity involved in trying to figure out how or what is the syntax that I need to uh, put into the cell and execute it so that my model is saved. So we do away with that complexity and we just provide you with a button which says save model. You click it, your model will be saved. And then you can use that model and you can load it again with the click of a button. And if you want to make predictions, you again click on a button which says predict, and you will be served with the predictions. We also have the ability to save the data that we produce in the DS Lab notebook. Namely, it could be plots, it could be several CSV files or text files or JSON files. So we can save them as artifacts, and those artifacts can be downloaded. They can be shared with the teams. That option is also there. One of the biggest and the coolest feature that we provide is productionizing the data science models that we produce out of our DS Lab notebook. So once you are thoroughly satisfied with the result that your model provides you in terms of accuracy or any other metric, then you can use that model and you can publish it to production pipeline. That is our production environment. So once the model is in your production pipeline, there is a component known as model runner, DS Lab model runner. That component will be part of a greater scheme of components and events in pipeline, wherein you ingest the data and you process it, and then you write to an RDBMS, another send data to other downstream applications. So this is also possible. And as I had briefly mentioned in one of the earlier slides, you can also publish this model as an API. Now, this is a very powerful feature. I gave you an example that you can consume this model as an API in any of the applications that you might want to create on top of this model. And I'll just show you a very cool application that we built, which is nothing but like a mobile application, and you just fill in the data and it will serve you predictions from the model that we would publish as an API. So what are the advantages of DS Lab? So as I had mentioned earlier, DS Lab provides us a one-stop ecosystem for data science professionals to perform their end-to-end project work. End-to-end. So when I say end-to-end, I mean end-to-end, right from the point where you are trying to figure out how to ingest data, from that point onwards, till the point you complete your experimentation and then try to figure out how do I productionize my model. So we provide you with all of that stuff, and it is all very simple. You just need to be aware of how, or you just need to get used to it. And once you are made aware of it and you are used to it, then it all becomes very simple. You know which buttons you have to click and where and when you have to click, and you will be productionizing your models to production at the click of a button. So data access is within the enterprise platform itself. Now, this is a very, very important feature which ensures security and sanctity of data. So we have worked with very large customers in the past, and such customers are global customers, and they are one of the largest Fortune 500 companies. And in their field, they are on the top. So these customers are very particular about the security of their data, from where the data can be accessed and who can access it. And they are also very, very particular about the sanctity of the data, the integrity of the data. So we ensure all of this. So we make sure that if a user wants that the data sanctity and integrity, security should be maintained to the topmost level, we ensure that by providing features from our platform itself, like data center, where you which is nothing but a centralized network storage location, and the data is stored in our platform only, and it can be accessed from there, and then it is made use of in the DS Lab notebook, and whatever model we create, we can again consume it in our production pipeline. So the data sanctity is maintained, the data integrity and security is maintained, and this is one of the sometimes it is one of the biggest requirements that the clients or customers are looking for. And with this feature, we really are ensuring this, because many times the client does not want us to use their data on a Google Collaboratory, for example, or the client does not want us to use their data in Jupyter Notebook in Jupyter Lab. Client does not want us to do that because Google Colab is not part of our platform. Jupyter Notebook from Jupyter Lab is not part of our platform. So the client does not want to use products that are not a part of our enterprise platform, because that compromises the security and sanctity of their data. So how do we solve that dilemma? How do we solve that problem? So yes, we can solve that problem with the help of DS Lab, and we have a notebook feature in DS Lab wherein it is connected within the platform itself, within the enterprise platform, and it is connected to the ingestion component or the data storage component, which is data center, that gives you option for data service and data sandbox, and to the productionize component also, which is the production data pipeline. So everything is within the platform. There's no compromise of data going outside of the platform. There's no chance of data going outside of the platform, and hence there is no compromise on those aspects. So data can be imported from any database. As I told you, models can be published to production pipeline for quick deployment, and it reduces the time taken to transition from experimentation to productionization. So this is something that I have been mentioning quite a number of times, and this is something that I would show you, and you would appreciate that it indeed reduces a lot of time, a whole set of process that comes into life when a data scientist actually comes up with a model. So that process entails using that model and trying to productionize it in any of the different cloud providers available in the market. So we try to do away with that complexity, and at the click of a button, people can publish their models to our production pipeline, and it gets productionized immediately. So obviously this results in increased productivity. The data scientists can no longer have to bother about how do I productionize this model. Once they are done with their experimentation and they have sent their model, they have published it to pipeline, they can start another experimentation, and like this they can keep on working parallelly on many different projects, and they can come up with models, and at the click of a button they can keep on publishing them in the pipeline. And this also results in reduced costs, and that is something that I don't have to elaborate about. So now I will take you through the DS Lab demo, and before I take you through the demo, I'd just like to inform that this demo has to do with a very simple diabetes use case. Now, the purpose of this demo is not to talk about the use case. The purpose of this demo is to make you aware of the different features that we are providing in DS Lab. So here we are not going to concentrate on the solution or the type of algorithm that I have used or why I have not used some other algorithm. That is not the purpose of this demo. The purpose is to make you aware of the different features of DS Lab, and for that we thought a simple example would suffice. And then I would just show you how do we consume this model as an API in one of the mobile applications. And then I would take you through the other part of the demo before we conclude with a brief discussion on the roadmap. So this is our production BDB platform. So in this platform, I want to start an experimentation. So before I start my experimentation, I would like to actually read data. And if I'm going to create a data science experiment, a notebook, for instance, if I want to create a notebook. So for that notebook, say, for example, this diabetes use case, I need a CSV file. So I will go to data center. I'll go to data center, and inside data center, I would upload a CSV file. So inside data center, I'll go to sandbox. I'll click on new. I'll just scroll down. I'll click on sandbox. And then I'll just come here, give some name, and I'll select a file. So once I select a file, I can just upload it to Sandbox. I can upload this file to Sandbox. I can click on upload and the file would be uploaded. So I'm not doing this because I already have this file available. How do I remove this? Okay. So I have uploaded, say, for example, a CSV file into my Sandbox. So people might have worked with Google Collaboratory. So this is how Google Collab looks like. This is the notebook, Google Collab notebook. So you can see I have created this notebook in Google Collab already. So I now have two things with me. I now have a data set with me, which I'm going to use in my notebook in DS Lab. And I also have a notebook with me, which I have created, in fact, in Google Colab. Now, what I'll do is I'll download this notebook. So I'll download this notebook. It will get downloaded as an IPYNB file. And you can see that it will be downloaded in my download folder. This is the notebook that I have downloaded. Now I can go to my DS Lab. So two things I have achieved till now. I have uploaded a data set. I have uploaded a data set to Data Sandbox, and I have downloaded an already existing notebook from Google Colab. Then I just go here to the menu and I click on DS Lab. So this is the interface for DS Lab. So this is the main screen that comes up, and it gives you, some idea what is happening here. So you can see projects. So this is the project screen, and you can see there is an already existing project known as DS Lab demo, and there's a description for the project, and it gives you the Git project link where we want to do version control management. So that is something that I missed to tell you. So we can also do version control management. We can push the code to GitLab. We can pull the version whichever we want from GitLab. That is also possible, and that's a very cool feature that helps us to do version management of the code that we have. And then you have resource allocation, idle shutdown. So we'll see all of these things, but usually the screen comes up blank if you do not have any project created. So we did two things till now, I uploaded one data set into Data Sandbox, and I downloaded one notebook from external source, which is Google Colab. So firstly, I want to create the entity called project. So project will have several things inside it. We'll see what all things it contains, which I've already spoken about, namely notebook dataset models. So I'll just call this project as demo2. So I just had clicked on the create project button and I came inside to this menu. I write the name of the project, which is demo2, and the description of the project would be DS Lab demo on 20th April 2022. I can give a name for the Git repository in which I want to put this data, and I can choose Python TensorFlow, because from the notebook that you have seen, you can see there are no PyTorch commands here. I have not used any PyTorch libraries. So Python TensorFlow would suffice. So this is just for the information of people that even if you have only simple machine learning commands that you are going to run in your notebook, you can still go ahead and use Python TensorFlow framework for that. The next tab is resource allocation. It gives you three options: low, medium, high, and depending upon the size of your experimentation and the volume of data that you're dealing with, you can choose either low, medium, or high. So in our case, the size of data is not very huge and the volume also is very low. So I can go with low resource allocation. But if you are working with data sets that are more than 50 MB in size, 50 megabytes in size, then I would suggest that you go for a medium or a high configuration for resource allocation. Then we have idle shutdown. So people who have already worked in Google Colab, they might be aware of this. If your session is idle for whatever amount of time that you choose from here, if it is idle for that much of time, then your session gets disconnected. So you might have to start your notebook all over again. So we have the same feature. So if I choose a feature, the idle time as 30 minutes. So if my session is idle, the DS Lab notebook session is idle for 30 minutes without any activity, then the session will get disconnected. So this is the external libraries that I was talking about. So if you want to for example, install certain packages like, I don't know, Boto3, XGBoost, and something from Azure storage blob, or things of that sort. So you can do that. You can just specify them here, one package name followed by the other, followed by a comma, and then the other package name. You can do that. That is also something it gets installed once the project is created. So I do not have to enter anything else. These things I don't have to change. I can just click on save. So now you can see I have created this new project. Demo2, I gave the description from the tooltip. You can see the description is DS Lab demo on 20th April 2022. And these are the different fields that I had populated. So what I need to do now, and if you have libraries, the libraries will appear here. So I have not given any libraries for installation. So what you have to do now is you have to activate this project. So I am activating this project now. Now, once the project is activated, you can just go inside. So what do you mean by activate project? So when you activate project, we are using in the backend Kubernetes services. So the Kubernetes pods spring into life, and they all allocate a pod specifically associated with your projects. So for this project, there would be a Kubernetes pod in the backend. So now I go inside this project, and this is how my project entity screen looks like. So you can see there are several tabs: notebook, dataset, utility, model. So I have talked about them in brief. And then you also have upload notebook, create notebook options. So what I need to do now is, if you remember, the first thing I did when I came to the platform was I went to data center and I uploaded I showed you how to upload a CSV file. I did not upload it because I already have that. So in order to configure that into the project, into the project, I need to click on the dataset tab. I need to click on the add dataset button, and the data sources currently available are data sets and data sandbox. So I told you, if you are planning to make use of data from some our database, an RDBMS or something, maybe SQL, MS SQL, MySQL, or MongoDB, PostgreSQL, then you might have to go with this option, and you might have to prepare your data set in data center. But I have not done that. I just need to work with a simple CSV file. For that reason, I uploaded, or rather showed you how to upload the CSV file to data sandbox, which is again a component of data center. So I'll choose the data sandbox option, and I will give the name of so I'll give the name of the CSV file that I had uploaded, and this CSV file is diabetes. So I'll add it now. So you can see this data set is now configured with this project. The data set diabetes, which is coming from data sandbox, it is now configured to be used for the project titled demo 2. Now I can go to my notebook, and if I want, I can create a new notebook. So I can show you how easily you can use this option to read the CSV file or data source of data ingestion and convert it into data frame. For example, I'll just click on this, and you can see some code gets pre-populated in the cell. Then you can just run this cell. Your cell is run. You can take this data frame. So this gives you a data frame here. So you can take this data frame and you can start your experimentation. So this is the data frame. You see how easy it is. Now this does away with so much of complexity. You need not bother whether this is a CSV file or an Excel file or a data set coming from a MongoDB collection or a data set coming from a PostgreSQL or data set coming from a Hive or a Cassandra. You can just click on it. You get a pre-populated cell with code. Just execute it, get your data frame, and you're ready to fly. You're ready to do your experimentation. You're not going to spend time here trying to figure out what is the syntax I'm going to use in order to read this data set. That's how simple we have made it for you. So anyway, I'm not going to, my intention was just to show you that you can use the create notebook option, and probably you can save this as well. So you can give any name, here. Yes, experiment. Okay. And you can also give a notebook description. So this is create notebook for diabetes use case for demo. So either you can do Control S, or you can come here and save the notebook. And the same holds true for executing the cell. You can either click on this arrow button, or you can do Shift Enter. Or the people who are data science professionals, all the keys that you make use of, as shortcut keys, all of them are available here. You can make use of all of them. So that's how simple it is. So this is the experience that you get here. It would not be any different from what you get on a Google Colab or a Jupyter notebook from Jupyter Lab or a Kaggle. So that you know what you have to do and where you have to find it. So we are not giving you something that involves a steep learning curve where you need to understand and get yourself familiarized. It's only the unique features that we have added to make your life simple that you need to know. And I think that will not take much time to understand. So I just created a small notebook, but my main intention was to upload the notebook that I had downloaded from Colab. So this is the notebook that I had downloaded from Colab, and now I have uploaded it here. So you can see this is a PIMA diabetes classification use case notebook. So this is the same notebook that I downloaded from Colab. So I'll just execute it now. and I'll show you what extra things we can do from DS Lab. So I'm just executing these cells, and now I need to read the data into a data frame. So what I'll do is I'll just click on this, my data set, and I'll get this code pre-populated in the cell. I'll just execute it. So I did shift enter. So people who work as data science professionals, they would appreciate that shift enter is working here. And just by doing shift enter, the cell gets executed. I want to see the data frame, the first 5 records. So I can see that as well. This is how my data frame looks like. This is how the data looks like. And then I have to start my experimentation. So you can see we have markdown cells as well. So these are markdown cells. This one and this one. These are markdown cells. So markdown cells are also whatever you can do in markdown cells in Colab or Jupyter Lab, you can do it here. Then I continue with my experimentation, and you can see I just did a describe and I got some statistical information. So now I want to create some plots. So with this set of code, I would like to create some plots. And you can see plots are generated here. So this is a scrollable bar. So this can collapse. So the side window gets collapsed, and you can scroll this up and down. Just if you have a very large image, you can scroll it. And if you want to see the side tab, just click on this, and the tab will again appear, and you can check the artifacts and the models that you have saved. So I already have, actually I have saved these plots as well. So the way to save plots is nothing but by using the plot.savefig function. So once I use that, I already will get these plots listed here. So you can see all of these plots which I created here. These plots are all saved now into artifacts. So you can see pregnancies versus outcome, pregnancies versus outcome, and all the glucose versus outcome, and blood pressure versus outcome. So all of these are saved in artifacts. If you want, you can download them. You can download them. You can view them. You can view the plots. Or if you want to delete them, you can delete them as well. Then I'm going ahead with my experimentation, and I create one more plot. I want to create a correlation plot. So you can see, just refresh this and you'll get the correlation PNG file also here. So this is the correlation PNG file. You can download it, you can verify. Then I come to the next section, which is nothing but to work with a model. So I am going to create the predictor variables and the predicted variable. So this is a supervised learning use case, and this is a very, very, very basic model that I have used. So I have made a disclaimer already at the beginning of this demo that the intention of this demo is not to show you the kind of solution that we have made for this use case, but to show you the different features using a very simple use case. So now I have fit a model on my training set. And this model object is contained in this variable model. So how, if I want to save the model now, I'll just minimize this. If I want to save this model now, what do I do? So I'll just create a new cell and I'll click on this button titled Save Model. This pre-populates this cell with the code that is required to save the model. So what are the things that I need to do? So this model name, the variable that you created there, which contains the model object, just specify it here. Model is equal to model, and you give a name to this model with which you would like to save this. So probably I'll give it a name of 20th one.pkl. Please note that I'm giving it as a pickle file. So currently we have only released a feature where sklearn models only can be saved, and sklearn models only can be published to pipeline. You can save models, PyTorch models, TensorFlow models, Keras models, but and of course sklearn models also, but you can publish only sklearn models to pipeline. So the feature of publishing TensorFlow or Keras or PyTorch models to pipeline is yet to be released, and it's going to be released quite soon. So Now my cell is populated. I gave the name for the model, and I gave the name for the model artifact as well. So I can just run this now. So once this is run, just refresh the model tab and go to unpublished models. If you go to unpublished models, you can see that model 20th_1.pkl is saved here. Now you have the option. Now you have the option to publish the model or delete the model. So we'll do that. We'll publish the model, but before that, I'll just show you another feature. So now you save the model at the click of a button. But suppose you do some more experimentation, or let us do this. So I'm doing some other stuff in the notebook. Okay, I'm doing some other stuff, and then I realize that now I want to use that model which I had saved. So how do I load it? So in order to load the model, there is no button per se, but what you can do is you can just click on this. Just click on this. So once you click on this, you can see this cell gets pre-populated with code, and you can see a variable named loaded model. So this contains the object of the loaded model. Just execute it. With Shift Enter, I executed it. Now my loaded model contains the model that I loaded just now at the click of this checkbox. So once the model is loaded, probably what you might want to do is to do some predictions out of that model, how good it is. Just click on this predict button. So once you have clicked on the predict button, you can see you are served with this pre-populated code. Now, this is actually, a guide, some comments that actually tell you how you need to populate the different parameters here. So if you are working with machine learning, experimentation, then you need to type ML here. If you are working with a computer vision experiment, then you need to type CV here. And that is something what is being described over here. And then it depends in computer vision. If you're working for Keras, then you need to give certain parameters. If you're working for PyTorch, you need to give certain parameters. So those are the things that are mentioned here. So mine is a simple ML experiment. So my model type would be ML, and my object, the model object that I loaded just now, is contained in loaded model. And what is the data frame that I want to do predictions on? So if you see, I already have my test set, which I had created just a minute ago. So I'll populate these values here, and I'll run this cell. So once I run the cell, you can see it serves me predictions. It serves me predictions. So for these different predictor variables, what is the prediction? So this person does not have diabetes. This person has diabetes. So this is how simple it becomes. So now you might want to evaluate this the accuracy in this. This is a classification problem in supervised learning. You might want to evaluate how good your predictions are. Then you can do the same thing and assign it to a variable. For example, I do this and I just type this out here and I assign it to a variable which I'll be using. So this variable will be nothing but a data frame. So I will say preds is equal to this. So preds is nothing but my data frame, which will contain the above data frame which you saw. So preds contains the data frame now, and I can show you that as well. So that's not a problem. Preds.head. To do that, you can see you have the same data frame which you got here. Now it's just contained in a variable named title preds, which is nothing but a data frame. So you need this column which has the predicted values. You need to tally it against the test labels. So you can just run the cell. So once you run the cell, you get some accuracy XYZ. So I have already made the disclaimer. My intention is not to give you a model that is 99% accurate, and that is not the intention. It's just to show you how do we use these features. So now you can see I created this notebook. I used the data set. I created artifacts such as images, and I saved them as well. And I used the save model, load model, predict model functionalities. And now I might want to save some other artifact. For example, I have created this data frame here, threads. So I want to maybe download it as a CSV file and maybe share it with my manager or my co-teammates. So this I can do by clicking on save artifacts. So once I click on save artifacts, I can give the data frame name as threads, and I can give it any name. Maybe I'll give pima.csv, and I'll just execute this. So once this is run, you can come to artifacts tab, or probably just refresh it and then come here. You can see pima.csv is there. If you want to download it, and make sure that you have the data as it appears in your notebook, you can just open it. So this is your pima.csv. So you can see it has all the columns that you saw in the note. It has predictions. So that's how we do it. So now if you're happy with this experimentation, if you're happy with the results, and you say that, yes, I want to productionize this model, how do I do it? Just come here against the model name. There are 3 dots. Click on it, click on publish. It will give you a pop-up. Click yes. Now the model is removed from the list of unpublished models. It will go in the list of published models. So you can see it has gone in the list of published models, and its color also has changed. Now this model is available in pipeline. So we can see that example in a little while from now. So there are 2 options actually. So once the model is published into pipeline and you are consuming it in your production pipeline, you can only unpublish it. You cannot delete it. Okay. So once you have published it into pipeline, you can only unpublish it. So only once a model is unpublished, that means it is no longer available in pipeline, then you have the option to delete it. That option will appear here once the model is unpublished. So what happens is we purposefully wanted to restrict any a mishap happening. For example, if you have published a model in pipeline and it is being used there, so if you try to delete it from here, then the model will be deleted from the central repo from where it is being picked up by the pipeline. So that can result in a disaster in your process, in the production process running in pipeline. That is something we kept in mind, and we disabled deleting a published model unless and until you unpublish it, remove it from pipeline, and then only you can delete it. So if you want, I can unpublish this. It gets unpublished. So go to the unpublished list of models. You can see unpublished models here now. And if you click on this, now you have the option to delete. If you want, you can delete it. So with this, I will go back and I will just save this notebook. Yeah, I have not changed the name. Whatever name I had downloaded it from Collab, I have used the same name. So with this, I just go back, and I actually did not add any description, but I had shown you how to add a description. So now the model that I saved, I need to publish it. So to use this model, so I had told you 2 things: publish the model to pipeline and publish the model as an API. So in order to make sure that a model is published as an API, I have to publish it to pipeline first. So I have to come here and I have to say publish. So this model is now published to pipeline. You can just verify it. So the model is published, so I can just go back. And I don't have to use dataset tab, don't have to use utility, I have to go to model tab. So now you can see this model is already published to pipeline, and it is listed down here. I can click on publish as an API icon, and I can push this model to API client registration. So this is the screen where I actually I am prompted with the different fields that I need to fill in order to publish this model as an API. So what are the number of instances that I can use in the backend? So depending upon the number of requests that you feel you are going to get for this model as an API component, you can give that many number of instances. So the minimum is 1, you cannot change it. The maximum could be anywhere depending upon what option you are looking for. So I'm giving it as 4 over here. And then you can take the framework here, you can take the environment, and you can take the resource allocation, and then you can say save and publish. So once you do save and publish, now this model is published as an API. So what we can do is we can go to admin, and we can go to API client registration. So I'm here in API client registration. I just now published a model, and I have two options here, internal and external. So right now we have not released the feature of external model as an API, publishing it as an external model as an API. We have only enabled the feature of model as an API internally, releasing it internally. It can be used as a model as an API in any of the applications that I have created internally. So I can give it any name, client, and I can give any email, and I can give the app name, app, and I can give request per hour depending upon how many number of requests we feel will hit this model as an API, and request per day, and select the type. So we have two options here, data as an API and model as an API. So this data as an API is nothing but exposing the data set as an API component, and model as an API is what we are working with right now. So I have chosen model as an API. And the model that I had published was model underscore 20th underscore 1, which is nothing but today's date. So I'll click on this, and I'll click on save. You can see the client name is here, client diabetes. So I'll just click on edit, and I'll be served with two fields, client ID and client secret. Now I'll go to Postman. Before going to Postman, I'll just copy this model name. I'll go to Postman, and this is my Postman collection. I can just paste the model name here. I'll go to headers. So inside headers, I have to give the client ID. So I'll give the client ID from here. This is the client ID, and this is the client secret. I've copied the client secret. I have to provide it here. And I have to give the app name. So what is the app name that I've given? App underscore diabetes. So this is app underscore diabetes. And I'll save this. Then I have to go to the body, and I have to give some sample data. So this is the sample data. If you would have seen, you have these different columns in my CSV file: pregnancy, glucose, blood pressure, BMI, insulin, age. So this is the data that I would like to pass to this model as an API, and then I need to see what is the result that I'm getting out of this. So I'll just send this data. So I send this data, and you can see it serves me a prediction that this the person with data of this nature with these values, it gives a prediction that the person is not diabetic. Now, how do we use this model as an API? What would be a sample application for that? So this is something that I had talked about. So you can see this is a sample application, mobile application. So let me enter some values here. Glucose could be 200, blood pressure could be 90, skin thickness could be, skin thickness could be 35 mm, insulin could be 100, BMI could be 35, 35, diabetes pedigree function would be 0.897, age could be 73. Now let me just calculate. So it gives me a prediction that the chance of diabetes is not seen based on the parameters. So you can change any parameter and you can experiment. So the model that I had published as an API. So if you see that the glucose level, as soon as so the glucose level and the insulin level both was same. That's why it said in the previous case, it said the chance of diabetes is not here, but now the glucose level is more than the insulin level. So we can see now it's telling you that the chance of diabetes is more. So this is using the same model that I have published as an API here. This model underscore 28 underscore 1.pkl. It is using the same model here and it is giving the predictions. So this is how cool this feature is, and this is one of the applications of this over here. Now there's one another thing that I would like to show you quickly, and that is how do we do version control management. So I have written a piece of code here already. I had shown you, I wrote this code here and I can push this code to GitLab. So let me just type this and say version 1 version 1. So I'll just copy this so that next time I don't have to paste. So now I push this to GitLab. So my code is now pushed to GitLab. Then I realize that I have to do some more experimentation, and I come inside the notebook. And only for the purpose of demo, I'm adding only one line over here. I'm not doing any elaborate experimentation. I'm adding just one more cell over here. And this will just say print done. Oh, sorry about that. Print done. Yep. So I have just added one more extra line and I do a control S. I save this notebook. I come out of this. So suppose my experimentation is done and I push this notebook as well. This is the notebook, which is the latest version with my changes. I push this also to GitLab. And then tomorrow I come and I have some requirement. I want to want to see which versions I can pull from GitLab. And you can see I have version 1 and version 2. And I realized the changes that I had made were not worthwhile to consider. So I want to pull only the old version. So if I pull this now, the older version, so this version of notebook will not have the print statement done. I hope you'll agree with me on that, because that was the only statement that I added at the end of the notebook. So this notebook will not have the print statement done. So this is the older version of the notebook that I pulled from GitLab. So now when I come down, you can see the last cell is this cell of save artifacts, and the cell that contained the statement print done in the newer version is not there because this is the older version that I pulled. So this is how we do version management from GitLab. And this is also, just on the click of a button, you are able to do this. Okay, so I had shown you how you publish a model to pipeline, and I had told you that in order to use the option of publishing the model as an API, you need to publish it first into the pipeline. So we have a similar example in the last webinar. My colleague Mani had run through the complete oil and gas use case. He had shown you the pipeline, he had shown you the notebook. So this is the notebook that was created last time for anomaly detection for oil and gas industry. And this notebook uses all of the features that I had just now demonstrated you with. All of the features that I had demonstrated you with for saving the plots, for saving the artifacts, for saving the model, for loading the model, for doing prediction, for publishing the model to pipeline. All of these things are happening here. So this is the notebook which was shown you in the previous webinar. So you can, sorry. So this notebook was used in the previous webinar, and you can see that the published model is model underscore. These two models are published actually to the pipeline. So if you want to if you have published a model, say for example, you have published these two models to pipeline because their color is already changed and you only have the option of unpublished. So that means they are published to pipeline. You can go to pipeline then. So just click on data pipeline. You will be prompted with a new window. Come here, list pipeline, and you can see this pipeline is already running. This is the machine sensors alert pipeline, which is using the notebook the model that I created out of the notebook. It is using this model. We'll see that. We'll see. I'll show you this model. So this model is being used here because I published in this pipeline. And you can come here. You can come inside, and you can see this is the DS Lab model load runner, which I was talking about. So maybe just expand it in this way. So this is the complete pipeline. So this is the complete production environment in which this model is already running. So this is a live pipeline. Data is being ingested and data is being written to the different RDBMS collections. So this is a live pipeline. And if you see here, so I have clicked on this component, which is the DS Lab model load runner. So you can see DS Lab model runner. So I'll just click on the meta information and I'll expand this. So you can see that after publishing this model to pipeline, so this model belongs to this project. This model, I told you there is a bigger umbrella, an entity called project. Project has notebooks, dataset models. So this model underscore RF belongs to this project anomaly detect. So this project is listed down here, anomaly detect. You have a lot of different projects available, but this is the project that we are going to use in this pipeline. And this is the model. So I told you that for this project, you have two models that have been published, but we are using model underscore RF. So this is the project, and this is the model. Both are published. The information is available. The model is published. The information for the project is available. Information for the model is available, and this model is being consumed here in this pipeline. So this is how we productionize the model, and it is just at the click of a button. As soon as you are done with your experimentation here, and you are happy with the results, and you're satisfied, you have showed them to your peers or your manager, and things look fine, then you just publish it, and you already have created an elaborate pipeline that is doing a number of things, and your model is also here, it is running, and it's doing its job. So this is how easily we productionize our models created out of DS Lab. And with this, I'll just go briefly to the PPT that I was using. So the DS Lab demo is done, and I'll just go to the roadmap and give you a high-level overview of what we want to achieve in the coming future, in the coming months. So we are going to release shortly the share projects and notebooks feature. So this will help you. It will, in fact, if you go and see here, the share projects and share notebook, this feature will be enabled. So you can share with anybody in your team or a user group, or if you want to exclude somebody, you can do that at the click of a button. So that feature, sharing of notebooks as well as projects, we can do that. And we'll be releasing that feature shortly. Then we want to release the feature of publishing PyTorch and TensorFlow Keras models to pipeline. So currently, I told you you can only publish .pkl models or sklearn models only to pipeline, and we want to include PyTorch and Keras models also. These are all pickle models, pickle files. Then we also want to enable. So this is something we want to make life more easy for the data scientists. So if you are going to use any algorithm, so how you got pre-populated code from here when you wanted to read a data set into a data frame. So like that will probably provide you with an option, and you click on it based upon the algorithm that you need, whether it is related to classification or regression. If you choose the algorithm, for example, a random forest algorithm, it will pre-populate the cell with the code, and you just have to change certain parameters and run the cell. So that is also something that we plan to come up with in the near future, and we'll release it. GPU support is going to be enabled so that you can run heavy duty stuff on PyTorch and Keras. That's going to be enabled in the near future. Then this is the utility model, which will also be enabled. So this is something that I had shown you, but not talked about it. And I would rather go here. So I had not talked about it. So this is the feature where it gives you an option to add utilities or Python script. So you can choose a Python script and you can add and then use that Python script in your uh, notebook. You can import it into your notebook and include it in your experimentation. So that is also something that we are going to release. And then we have the AutoML feature that we plan to release by Q4 2022. So that's going to be a hot feature, and we have made good progress on that. And I believe that will be a very good addition to the set of features that we already have on this. So thank you very, very much.